All right, well, my clock is showing 11, so I think we'll get started. Thank you, everyone, for joining us today for the webinar. My name is Camel, and I'm here with Craig Spears, and we will be doing the webinar today on optimizing the geometric design of highways. We'll talk about our new optimization software program called Softree Optimal. The webinar today will be recorded, so you'll all receive a link to the recording if you'd like to watch it again or pass it on to anyone else who was not able to attend. And also we have a question panel. You are muted, so you aren't able to talk to us, but you can type in questions in the question panel. We'll try to keep an eye on it and answer them as we go, so feel free to type in any questions that arise as we go through the webinar today. So just a brief outline of what we are going to be talking about today. I'm going to quickly do an overview of some of the concepts we'll be covering today. I'll talk briefly about how optimization works to start with in the context of geometric highway design. I'll also talk about how optimization fits into design workflows and how it can improve the design process for designing a highway. I'll also talk briefly about the costing data that Softree Optimal provides and how this allows engineers to design smarter. And after this introduction, quick PowerPoint presentation, I'll pass things on to Craig, and he will show you how to do all of this with Softree Optimal using a project in Civil 3D as an example. So first, how does optimization work? Have you ever thought it would be useful if you had a tool to help you design your vertical alignment by taking out some of the trial and error? That is exactly what Softree Optimal does. Softree Optimal optimizes the vertical alignment of a road or corridor by mathematically minimizing earthwork costs. It solves the complex 3D problem of minimizing excavation, embankment, and haulage given your user-defined constraints. So this optimal solution is determined based on your geometric design data. The original ground surface, as you can see in this slide, these four things: the original ground surface, the existing horizontal alignment, and the cross-sectional data taken from, in this case, a Civil 3D design, as well as the design parameters, constraints, and unit costs that are entered by the user into Softree Optimal. A demo today what these costs and constraints are. And the result is an optimal lowest cost vertical alignment as well as the associated costing data and a detailed earthwork movement schedule. And this process is quite fast, and optimal alignment can be generated often in a matter of minutes. It's not a huge software program that takes hours or days to process information. It's very fast. So the ability to generate an optimal vertical alignment has benefits both at the beginning and at the end of the design process. So at the beginning, Softree Optimal can be used for feasibility checking in the preliminary design stage. It can also be a means for quantitatively comparing multiple design variables at the preliminary design stage to determine the lowest cost options or baseline starting point before getting into detailed design, starting off with the lowest cost possibilities helps you to determine finalized design that is also the lowest cost. An example of this would be comparing multiple horizontal alignments based on cost, or comparing the effect of different grades or different curve geometry, comparing the effect that would have on your construction cost. And then your detailed design, second part of this slide, can be done in your existing CAD design program, whether it is Civil 3D, Inroads or Bentley Civil Design Products, 12D, or Softree's own easy-to-use road design package, which is called RoadEng. Today's webinar will be using a Civil 3D design, but you can use pretty much any of the standard CAD programs out there. So have you ever completed a design and wondered if it could have been better? Or have you ever wanted to check a design received from someone else to make sure that it satisfies all the design criteria? Softree Optimal can also be used to check a finalized design, to perform a final optimization to determine the lowest cost alignment, and also for estimating construction quantities. The costing data that Softree Optimal provides is unique and offers a new way of thinking about geometric design, which is going to be really the focus of the webinar today. It brings construction closer to design by giving engineers visibility with respect to their earthwork costs while they design. So it's really bringing those two worlds of construction and office design closer together. Currently, civil engineers make decisions based on many types of design criteria. Safety, for one, number one, right-of-way, and there are many, many others. But what if you could also make design decisions based on construction cost? Now, of course, this can already be done. Engineers do make design decisions based on cost, but these decisions are based generally more on experience or on other quote-unquote soft criteria. There isn't really any way to compare two designs and know quantitatively which is cheaper to construct, because a balanced road is not always the cheapest road, and cuts and fills aren't all that matters either. Material movement, how much is moved and how far, makes a huge difference in terms of construction costs. So really it's quite a complex process that involves lots of variables. So Softree Optimal puts this detailed costing data in the hands of engineers to allow them to make cost-effective decisions, and also to provide stakeholders with the economic consequences of constructing a road based on certain criteria. So it can allow a consultant to go to his client and say, well, if you want this grade, this is what it's going to cost, versus, or this design speed, this is what it's going to cost, versus if you're more flexible with some other design criteria, this is the price tag. It really allows engineers to make these quantified design decisions based on construction cost. And the end result is that they're able to design a lower cost highway, road, or corridor. So Craig will show you how this is done, and with a real highway project done in Civil 3D. But before I pass things on to him, I'll just show you a list of some of our upcoming webinars. So feel free to sign up for any or all of them. Hopefully you like the one today and you'll want to join us for more. With that, I will pass things on to Craig.
Good morning or good afternoon, everyone. First of all, make sure you can see my screen. Are you seeing my screen?
Yeah, you're all good.
Good. Excellent. That's the hardest part of the demo. Yes, well, I'm going to be demonstrating a highway project using our Softree Optimal software to minimize earthwork quantities. And I think before I get going, I just wanted to talk a little bit about some of the things that Cam has talked about, in that Softree Optimal will not necessarily give you the best alignment. What it will do is it will give you the lowest cost alignment for a certain set of conditions. It does not take into consideration many of the things that engineers have to deal with, like safety, environmental footprint, drainage. All those problems are still clearly on the desk of the engineer. Softree Optimal is a tool which you can apply to help you come up with an alignment which satisfies all your conditions. And I expect that in many cases that the output from Softree Optimal would not be the final alignment that is used. Instead, it would be like a baseline. You can very quickly determine what the cost of changing certain parameters, what the effect is on the overall cost. So it's really just a tool. It's not a black box, be-all, end-all solution. So the project that I'm going to demo is a project from Northern Canada. It's a 4-lane highway. It's about 9 kilometers long, and I think it has a design speed of about 100 kilometers an hour. You can see here in the Softree Optimal environment, I'll show you quickly, it's a road coming off an existing highway, and there was formerly a road along the lake here. It's being relocated up into the side of the hill, and a higher speed road is being put in, and it's reconnecting back over here, avoiding, I think, some property issues, maybe some stability issues down by the lake here. So it's sort of a classic realignment project. This project started in, we were given it in Civil 3D. I'll just quickly bring that up. I won't go through the process of getting it from Civil 3D into Softree Optimal. It was fairly straightforward. Here in Civil 3D, we've got the same alignment, and we've got, we were given a profile along with cross sections and so on. To get it out of Civil 3D, I simply exported the original ground surface. I exported the alignment features, the center line alignment, and I exported them as XML, export to XML. And I also used a plugin that we provide for Civil 3D, which will capture the cross sections, the corridor assemblies, and so on, so that we can pretty much emulate the behavior of those things in Softree Optimal without having to recreate all the cross sections. So very quickly, I can take a project that was created here in Civil 3D and bring it into the Softree Optimal environment. So let's go back to Softree Optimal, and here is our environment. And the first thing I'm going to do is ignore the alignment that I was given and demonstrate how to create an alignment from scratch, assuming that I did not have any vertical alignment to start with. So I'll just select this profile that's taking me back to an original ground situation. By the way, the cross section, as you can see, there's a 4-lane highway, depressed median in the middle, and this has come pretty much directly from Civil 3D. So if I look at this, I'm going to get, if I move it vertically, and the little tick marks there are where we've sampled it in 3D, we're going to get a behavior that is what Civil 3D would have done with the assemblies and so on in Civil 3D. If I didn't want to go through Civil 3D, and by the way, we interface also with Bentley products, we have other options for creating the cross sections. You can create the cross section in this environment directly, so you don't necessarily have to go through Civil 3D. Similarly, you can bring in surfaces from other software and get cross sections from those surfaces. It's a bit of it's another topic, so I won't linger on that, but suffice to say, you can quickly get the cross-sectional information into this environment. So I've reset my profile line to the original ground line, and I want to get quite quickly a profile for this. And I'm just going to go ahead and do this, and I'll backtrack and explain how I did it and what the factors were that were used. So in my case, I'm going to choose sag and crest values. I've got these set, and also minimum and maximum grades. And I'm going to choose a type of optimization, a little bit technical, called variable curves and tangents. And I'm going to give it a minimum curve length and also a minimum tangent length. These are things that you can try different combinations of. I'll talk a little bit more about that in a second. Let's just go. I'm going to also add a couple of control points. I'll add one at the start of the alignment because we're coming off an existing road. And I'll also add a control point at the end of the alignment. because we match back into an existing road. And I'm going to tell it that I want to match the grade coming off the ground, assuming the ground was on the existing road at the beginning. So get the grade there, and I can give it some tolerance for the grade. That just gives the optimizer a bit more flexibility. Let's just go with that. So I'm going to press OK, and I think I didn't new. Let me just try this. CNG. There we go. I wanted to keep this separate and create a new one. Check. I've got stuff I set. Yes, perfect. Okay, so now I'm going to process a optimal vertical alignment from scratch. Process button here. Now what it's doing is it's calculating some costs. I'll explain those a little bit better. It's doing some pre-processing, and in a minute it's going to go into the hardcore optimization. Cam mentioned that it takes minutes. That's not always the case. In some longer projects, if you have a 10-kilometer road, 20-kilometer road, it actually can take hours to do this process. Generally, though, for moderate length roads, it's pretty quick, and we can get a solution fairly quickly. I've run this one, and I know it takes a few minutes to come up with a solution. I believe. Slow down because people are watching. Okay, it's got a solution. What this is telling me now is it's found a solution, and that's the cost of the solution. And this parameter here is quite interesting. It's telling me that it's only 12% away from the best it can be. And I watch that gap, and as it gets down to something that I would consider small, I'll just cancel and accept the solution because the tail end of the processing can take a fair amount of time. And it's busy thinking. I'm going to let it run for a little bit, and we'll get that gap down to something reasonable. Oh, where'd it go? It's popped under. Okay, so it's down to what I would consider to be a reasonable first pass at an alignment. So I'm going to just cancel this. It says partial solution only found. You sure you want to cancel? Yes. It's telling me some information about the optimization. Let's reposition my window here. And there I've got an alignment, and it's done this from scratch. It's only taken me a few minutes. It's done it from scratch, and it's given me a total cost. Total costs include, or a breakdown of that is a cut cost, fill cost, haulage cost, and the volumes are also broken down into various volume categories. So very quickly I can get an alignment for a given horizontal alignment, and I get a vertical alignment, and I can get a cost. So that alone for sort of exploring corridors and routes is very valuable. And yeah, so how did it do this? Let's have a closer look at some of the details. First of all, the costs. That's always a good starting point. The calculation of costs is done by material types, and in this situation I've only assigned one material to the entire ground beneath the alignment. And with that material I have an excavation cost and an embankment cost. and those, of course, are user definable. You don't have to get them perfectly to compare alignments. Reasonable values there, of course, are worth doing. Now, the tricky or interesting part of Softree Optimal is the haulage calculation. As Cam mentioned, that can be a significant part of it. And what this software does is it will actually optimize the best way to move material around, and I'll explain that a little bit later. And from that optimal schedule of movements, it comes up with costs. So at design time, you're getting a pretty good look at what your haulage costs are going to be. So the haulage costs are set by each class of equipment. Your free haul equipment, probably a dozer or a shovel, and it's got a hauling cost, usually quite expensive, and a loading cost, which is usually insignificant. And then the overhaul might be an equipment like a scraper, where your hauling cost has come down quite a bit, but now you do have some loading cost. And finally, end haul, which is truck material being trucked, and it's got a hauling cost, quite inexpensive, and a bigger loading cost. So those three categories and their cost define a curve, and they define the economic distance of what is free haul. And yeah, that's the science behind it. The free haul distance is really the distance to which you can move material that's economic. Beyond that, it just becomes economic to move using that type of equipment. So based on that, the optimizer will calculate a cost for a given alignment. And I'll just go back to the user alignment that we were given for a second to show you how costing can be done very quickly in this environment, not only with an optimal environment, an optimal alignment, but a hand tweaked alignment as well. So first thing I need to do is set auto calculate. That's done. And I can come here, and if I grab one of these vertical intersection points, maximize this window. I've got the mass haul graph down here. Notice that the cost here is telling me the total cost of this alignment was $688.7, 6 million, almost $7 million bucks. If I move that alignment a little bit, so move it to cost, and I've added some cost to that to alignment by perturbing it very slightly. An interesting thing about Optimal is that for projects like highways, like railways, where you've got some fairly severe limitations in terms of you need very smooth curves, you need gentle grades, Optimizer works very well for these kind of projects. I would say it works better than lower standard roads like resource roads, where the tendency is simply to follow the ground. You can't do that in a highway. You need nice gentle curves, and you can't follow every dip and bump in the ground. So the optimizer is really good for this. And this real-time costing is a byproduct of the optimizer. So let me undo that change. I'll screw this up and come back to the overall problem. So we were given anyway an alignment, and I want to know if I could maybe improve on this alignment. So what I typically will do is I will get it and I will optimize it, and not only will I let the optimizer choose where it wants to put curves, I will force the optimizer to put curves where the user has put curves. So I'll call this user curve, user curve option. So it's preserving the location of the begin curve and end curve. Obviously, when you're designing highways, you need to be aware of what's going on horizontally. You don't want long tangents with a short vertical curve at the end of the long tangent. Things like that, where the lowest cost solution just won't be satisfactory. So with this curve type option, user defined, I'm telling the optimizer to stay with my curve locations, but look to optimize them. So everything else is pretty much the same here. Again, I have to add some control points, start of the alignment, and I'll add one at the end of the alignment.
Craig, we have a question as well about right-of-way.
Okay, let me get this going because it might take a couple of seconds.
Let me know when you're ready. I'll read it.
And I'll come back to that one. So just have to keep handling what I'm doing here. Original ground. So there's a reference alignment. And yeah, I think we're good here. Let's just go ahead and do this. So this will preserve the curve locations that we've got. Process this. Okay, give this a second. What's the question?
So the question is, what about right-of-way constrictions? Will the program keep the road in the right-of-way? Examples such as top of backslope and ditch cuts.
Yes, that's a very good question, and the answer is yes, we can do that. We have, and I'll explain that a little bit more, we have a whole bunch of different ways to constrain an alignment so that, yes, it falls in right of way, or it matches a control point or a range of elevations because you have an intersecting road or utility that you have to cross, things like that. So you can control it. By the way, we're down here to a very small optimality gap. I'm going to just say that's good. And now I've optimized that alignment. And if it, just look at the cost of that, compared it to the original. Very similar, which I guess is good. But it's a little cheaper. You can see there it's about 8% cheaper, but it's been tweaked. You know, it's doing a little more filling here than the original, but it's preserved the same curve locations, which is nice. So it's a nice way to control the optimizer because you don't always make decisions based on lowest cost. You need to consider safety and those other things. So yes, constraints, that's a timely question. Let me talk a little bit about constraints. Here is the optimization that I just ran, and this band is the band which I told the optimizer I can work in. So I've set that in here. I've said general. I can go plus or minus 10, and that's my band, plus or minus 10. Now, one type of constraint that's pretty common is to put a control point in. Let's say I have a utility here somewhere. Wild guess here, say at 16. I wrote this down. 16104. 04. Sorry. Add a new control point. Well, first, sorry. Get from the alignment. Add a new control point. Station 16104. Fat fingers this morning. There we go. Station 16104. I'm going to set the control point elevation to 218. So I'm going to force the alignment through that control point. And I could also give it a tolerance. I could say I can go a meter or two above or below that point. So it's quite often useful to do that, giving the optimizer a chance to move things around a bit to reduce costs. So let's just go with that. I'm going to go through that exact elevation at 16104, process this. Oh, well, yeah, okay, we're quickly at a solution, which is nice. I'll cancel. We can just have a look at what it's done there. Zoom to my control point, which I'm not seeing. There it is. So there is the station, 16115, and I've told it to go through that elevation, 218, and it has. And so the band has come down to that point, and the alignment goes through there. So you can force the alignment to do things. Some other constraints, which, to get back to your question, there's called the vertical horizontal right-of-way constraints, which allow you to, how does this work now? Active, minimum, maximum. Constraints limit the horizontal extent of cut and fill. So by using this constraint for a station range, you can stop the alignment from encroaching on right-of-way. I don't think I'm going to do that because I think adding right-of-way constraints starts to take a little bit longer to process, but it can be done. Some other constraints that are often used in an area that's a poor material or something, you can have a minimum fill height above it. Classic for that is sort of northern muskeg situation where you need material on top of the road, so you force a minimum fill. Steep ground, you need to a full bench cut, and so on. So all these constraints do is they clamp the alignment down and prevent it from moving in places that might be cheaper for various reasons. Yeah, let me talk a little bit about material movement, because that's quite important. Down at the bottom here is my current alignment is actually still my hand engineered one. So let's set this alignment current. How are we doing for time? Oh.
We're at about half an hour.
Okay, so I'm going to speed up a bit, but not too much. If anyone wants to take off, this will be recorded and come back to it. So I'm going to retrieve a layout that shows me how my material is being moved around based on that alignment. So I'm back here. To configuration for the screen, which is showing me my material movement. And down at the bottom, sorry, the mouse seems to be stuck, is a graph which is broken into those three classes: free haul, overhaul, end haul. And it's showing me the direction of movement of material in each of those classes. So you can see here in the alignment that material is being moved. It's being filled in here. It's still moving forward and being moved into this fill, and further over, material is being moved into this section here, and particularly this section here. So all the material movement is being calculated, and again, this is based on an optimization of the best way to move material around. So as Cam mentioned, quite often people say, oh, I balanced my road, but the balanced road isn't necessarily the lowest cost road. It is, there's different ways to move material around, and a balanced road can be balanced in many ways. So this will calculate the optimum material movement, and the alignment will be the lowest cost. On the subject of material movement, there is an ability here to put in some pit locations. I didn't do that, and if you don't do that, it will try to balance the road. But if I wanted, I could have added some borrow and waste locations. Say I want to put in a pit at the beginning of the road, I can make it a borrow or waste pit. This checkbox, quite quite interesting and important. It will nominate the pit as being a smart pit or variable pit, and it will only use the pit if it needs to. So you can have a whole bunch of pit locations, borrow and waste, and you can choose to set them as variable pits, and it will open them if it needs to. So there is, with a pit, there is a cost for opening the pit, and there may be some distance from the alignment that the material has to be hauled, so it will use the cost of hauling to determine the cost of getting the material from that pit. So the opening cost and the cost of hauling will determine whether it's economic to open the pit and how much material you need to move there. Very briefly, this is not only useful for designing roads, it's useful for calculating and estimating construction quantities and movements. I was going to briefly show you the ability to add multiple materials here. I've only got one material. If I wanted, I could assign some layers below ground. So I could, for instance, take overburden and put it on top of solid rock and give it a depth. So I got 2 meters of overburden on top of solid rock, and we calculate, and there's a constant layer thickness. If I was more sophisticated, I could bring in a surface with that rock depth as a regular tin surface and use that surface for calculating rock quantities. Now when I go to optimize, it's going to consider the costs of those things, and the cost of solid rock is really expensive. It's got to blast it, so it's going to try and avoid it if it can. And I did a run just before I got on here and found that it tried to avoid it, but it couldn't actually. It ended up being fairly similar to the original alignment just because of the curves and the control points and so on. It just could not avoid the rock in some places. The other thing I want to quickly mention, and I'm not demonstrating these due to time constraints, but the ability to put in composite materials or unusable materials. So I've got some ground type here. I can create a new ground type. It's called a comp, and it's made up of 2 materials, and one of them is unsuitable for, I'm going to add overburden. Oops, I have to give it a positive percent, 20% overburden, and let's say gravel for 80%. And if we look at the quality, there's a thing called the quality of gravel. It's a quality factor 3, whereas overburden is a quality factor 1. So if I do that and I assign gravel somewhere, it will, if I tell it, I put in a fill type here and I tell it that fill material has to be quality 2 or better, the equivalent of hard pan, quality 2 or better, replaceable. It will not use a percentage of that composite material. It will be forced to be wasted and not built into the road. So there's quite a bit of flexibility in the way you handle materials and what's reusable and so on. The final thing I wanted to show you, if it isn't obvious, is that I can change horizontal alignments and try another horizontal alignment position relatively quickly. And I have done that, and I'm just going to open one of those up. I should just save this case. Option C. So I perturbed this alignment just to give it a try. I wasn't actually sure how long this demo would take, so I had a little extra material to go on. But yeah, here I've taken the alignment, that original alignment, which was in pink, pinkish magenta, and brought it down this slope here at a gentler grade because it was constrained by the grade, and I re-optimized it. I cheated a bit. I didn't go back to the Civil 3D cross-section. I used a Softree Optimal template that was similar. I re-optimized it, and I got a lower cost from that repositioning horizontally. So my point is you can move the horizontal alignment around fairly quickly, and using this tool, come up with some costs, make decisions based on those costs, and so on. And that was pretty much all I had for today. We have had lots of other seminars talk about different parts of Softree Optimal in a bit more detail, but this has been on highway design. And again, as I mentioned, highway design is really well suited for optimization because of the wide footprint of the road. The gentle curves and gentle grades make finding that optimal solution very useful, because small changes in vertical position can actually translate into huge dollar differences and may not affect the drivability of the road at all. So it's kind of a nice way to tweak a design and or quickly get a new design. So that's it. Any questions?
Last call for questions, everybody. There was an earlier question about the recording of the tutorial session, which I just answered individually, but for anyone that didn't catch that, we did record this, and you'll all receive a link. So don't worry about that. Any other questions, or should we call it a day? All right, well, thanks everyone for joining us today. Have a great weekend, and you'll all be receiving a link to the recording probably early next week. Hope to see you again at one of our next webinars.
Thanks, everyone.